In this lesson, you will find squares of sums and differences. So what is a square? What they'll look like today is it'll be a binomial with a power of 2. And what that really means is you're going to take x minus 2 times another x minus 2. It's that binomial squared. Or it might be a sum, like x plus 2. And then you would take x plus 2 times x plus 2. What's really cool about these is there's a certain pattern. It will always look the same, so you won't have to use FOIL or boxes. You can actually use the pattern, and it goes a little faster. We'll also find the product of a sum and a difference, and what that looks like is I have x plus 2 times x minus 2. And when you multiply these using FOIL or boxes, it's always going to be the same pattern. So we can just use the pattern instead of FOIL or boxes, so we don't have to show any work. It's just a faster way to multiply. So let's watch what happens using FOIL. This is a sum, and it's squared. So that is actually taking x plus 3 times x plus 3. So we would have to separate it out. We would have to use FOIL, so that'd be x squared plus outer is next, inner, and last. And what you notice is we have the first term squared plus this is the double of their products, that'd be 6x plus 9. Watch what happens when we FOIL this difference, and let's see how they compare. We would have x minus 3 times x minus 3. Let's FOIL it. First, outer, inner, last. And what you notice is you still have that same pattern, but the signs are different. So when it's a sum, it's all pluses. When it's a minus, we have a minus, then a plus. What else we notice is it's that first term, x squared, that last term, 3 squared, and if you look at their product, 3x, it's the double. It's 6x. And that pattern is what we're going to be able to use. Let me just show you how this works with the formula here, with this model. That first term is going to be squared, product plus product, and last term squared. So it's always going to fit this pattern. So this is a rule. Any sum squared is going to be the first term squared, double the product, and the last term squared every single time. So let's just use the pattern. The first term is 3x. Let's square it. That would be 9x squared. The product is 15x. Let's double it. That would be 30x. And I'm going to make it plus because that's a plus. The last term is 5. Let's square it. That would be 25. And we're done. Now, if you don't believe me, then use FOIL to check it. But this is the pattern. First term squared, 8c. That would be 64c squared. Second term is doubled the product. Well, that would be 24cd. So let's double it. That would be 48cd. Last term is 3d. Let's square it. That would be 90 squared. So you try the example of a sum, a square of a sum, in your notes. Now, how does a difference look? Well, in this difference, sorry, wrong slide here. In this difference, everything is going to be the same except our term, our middle term is going to be a minus. So we'll do first term squared, that would be 4x squared. And then we have a minus product, that would be 10xy doubled, 20xy. Last term is going to be plus 25y squared. First term squared, product doubled, last term squared. Follow that pattern every time in a square of a difference. So here is 6p minus 1 squared. This is a minus, so I know my middle term is going to be minus. Follow the pattern. That would be 36p squared minus 6p times 1 is 6p. Double it, 12p. And then we have 1 squared. So this is your product. Try the example of some squares of differences in your notes. Now we're going to talk about what's called a difference of square. When I take a sum times a difference, I'm going to show you what happens with FOIL, but this tells you the pattern is going to be the first term squared minus the last term squared every time, and we call that a difference of squares. So let's go ahead and look at that difference of squares. Here I have 2 squared plus 3 times 2 squared minus 3. This is the difference of square because this is a sum and a difference. Let's go ahead and FOIL it and see what happens. First would be 4x to the 4th, outer minus 6x squared, inner plus 6x squared, last minus 9. See how that middle term cancels out? And so this pattern that you can use every time, when you see a sum times a difference, do the first term squared, and then subtract, and now have the last term squared. Do you see how this is called a difference of squares now? First term squared, last term squared. So let's use the pattern here. See how this is a sum and a difference? So we can follow the difference of squares pattern. First term squared would be 9n squared. Last term squared would be 4, and it's a difference of squares. Wow, a lot less work. You don't have to FOIL, you don't have to use boxes, just use the pattern. So try the example of a difference of square in your notes. Let's just review really quick here. The square of a sum is always